In this video lecture, we are going to see how to print the left view of a binary tree. So if you talk about the left view, suppose this is a tree, this is a pictorial representation of a tree. The left view will be the leftmost node which is coming if you see the tree from the left hand side. Suppose you are at this side, and from this side you will see this tree, then you can see this 2, 5, 11, 4 and 6. 7, 21, 9 will not be coming because these will be hidden through these nodes. 7 will be hidden because 5 will be coming in from the left hand side, 11 will be coming in the left hand side, so 21 will be hidden, 4 will be coming in the left hand, so 9 will not be visible. So in short, the leftmost node which is coming at each level can be considered as the left view of a binary tree. So the output which will be coming in this place will be 2, that is this 2, then 5, then 11, then 4 and 6. So one way to compute the left view or to print the left view is that you can first calculate the height, that is height of binary tree, and for each height, that is your iteration will become I equal to 0 till I less than height, and for each height you will be taking the first node which is coming out by iterating for in a, you can say, pre-order traversal. So left hand side which will be the first node, and for this will be for loop for calculation of at each level. Somewhat like this will happen. So as you can see, for the height of a binary tree, that it itself is a O of n, this for loop, and again what you are doing inside this, you will be calling print left and iterating the whole tree at each level, and whichever the tree will be coming out at that level, you will be printing that. So inside this will also be one more loop, so it will be O of n square. So we are not going to see this logic here, we are going to see the efficient solution to print the left view of a binary tree in this tutorial. So in this lecture we will see how to calculate the height, not the height, but print the left view of a binary tree using O of n time complexity. Regarding calculation of height, I have created one more video lecture. You can click on this bell icon which is coming out in the top, that is the I button, and also I'll provide the link in the description regarding calculation of height. And that calculation which I have provided, the lecture which I provided regarding height calculation, I provided a logic to calculate height of a binary tree in just 2 lines. It will be a 2-line code only to calculate the height of a binary tree. So you can check it out in the description. Okay, so now the thing is, to print the left view of a binary tree, we are going to start with a queue data structure, and we will pass the node inside it. So I will call it as queue. It will be new linked list. So the thing is, I will pass the first node, that is the head node, inside queue, and I will iterate while queue is empty, that is queue dot size comes out to be greater than 0, then I will keep on iterating. I will check the size of queue at each iteration, and I will append all the nodes at that level inside the queue by putting I equals 0, I less than size I plus plus. And if for that I will pull out node at each level, the first node at each level will be queue dot poll, and if I equal to 0, then it's the first node. I'll simply print out that node because we are appending the first node as left node only. So and dot data, I'll add a space here along with a comma so that it will be coming out as our output only with this comma. So if this node is not null and if this node dot left is not null, we'll just put that in queue. If and dot left is not null, just add q dot add and dot left. Similarly, if n dot right is not equal to null, q dot add n dot right. This is how the whole scenario will work. So this is the only solution which I was talking about. As you can see, though this is a while loop, it looks out that it's a O of n square, but the thing which you are doing is inside this queue you are appending each node one time only. So the iteration will happen for all the nodes at one time only. So you are adding all the nodes and pulling out the first node only, and after that coming out of the loop because the queue size has exhausted. That's it. This loop was required for each level iteration, and this loop is for checking the queue dot size. So in short, all the nodes which will be added in the queue is one time only. So the time complexity it will give is O of n. This is the efficient solution to print the left view of a binary tree. If I run this code, it will print out the data. Let me remove this ln part so that the result will come out in the one line only. So 2, 5, 11, 4 and 6. So 2, 5, 11, 4 and 6 is the left view of a binary tree. This is how we can go with the left view of a binary tree. If you want to go for the right view of a binary tree, no need to do anything. Just pull out this data and add right view in the front. So whatever the node which will be pulled out at ith index will be the rightmost node. So if I put the right view of a binary tree, you can see 2, 7, 21, 9 and 6. So 2, 7, 21, 9 and 6. This is the right view of a binary tree. So I have shown you how to print the left view of a binary tree and right view of a binary tree in one lecture only. Thank you all for watching the video.